Welcome to the unit on equations and inequalities, linear inequalities. The objectives for this session are to solve linear inequalities using manipulation and number lines. Linear inequalities can be solved using methods similar to those for solving linear equations. Take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's begin by solving example 1a. We rearrange the equation to give 4x plus 7 is greater than or equal to 35. 6x minus 2x is 4x, and 7 and 35 stay as they are. We rearrange further. 35 minus 7 and leave 4x as it is. We tidy up. 35 minus 7 is 28. And finally divide by 4 to give x is greater than or equal to 7. So in notation, this is x such that x is greater than or equal to 7. Now for example 1b. We rearrange the equation to give 9 is less than 5x minus 1. Here we're making the x positive, and we leave 9 and minus 1 as it is. We move 1 to the other side, so we have 9 plus 1, and leave 5x as it is. Then we tidy up. 9 plus 1 is 10. And then 10 divided by 5 is less than x. So in notation, this is x such that x is greater than 2. Now let's solve example 1c. We expand and rearrange the equation to give 4x minus 8 is greater than 7 minus 2x plus 6. So expanding one set of brackets gives us 4x minus 8. We leave the 7 as it is, and the second set of brackets becomes minus 2x plus 6. Then tidying up, 4x plus 2x is 6x. We leave the other numbers as they are, and then tidy up some more. 7 plus 6 becomes 13. Now we take the 8 over to the other side, or add 8 to both sides, giving us 13 plus 8 on one side, and the 8 on the other disappears. So we're left with 6x is greater than 13 plus 8, which becomes 21. And then dividing through by 6 gives us that x is greater than 21 over 6. And 21 over 6 is equal to 3.5. So in notation, we have the set x such that x is greater than 3.5. Sometimes two inequalities are true simultaneously. Now number lines can help us find solutions. Take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. Example 2a asks you to express the following more concisely if possible and using set notation. The solution set is x greater than minus 3 and x less than or equal to 2. So let's solve this. We will use diagrams to help us. We begin with the number line and find the region x greater than -3. Notice the end value is not included. This is denoted by a circle which is not shaded. And the bit x less than or equal to 2 is as shown. Notice this time we have a shaded circle which denotes that the end value is included. If we're looking for the region x greater than -3 and x less than or equal to 2, then both have to be satisfied simultaneously. So x has to be greater than -3 and x has to be less than or equal to 2, giving us in notation that the solution set is a set of x such that -3 is less than x is less than or equal to 2. Or alternatively, x such that x is greater than -3 and, or intersected with, x such that x is less than or equal to 2, as shown. Now for example 2b, we're required to express the following more concisely if possible and using set notation. The solution set is x less than or equal to -2 or x greater than 3. So let's solve this. Again, we'll use diagrams to help us. We begin with the number line. X less than or equal to -2 is as shown. X greater than 3 is as shown. And in notation, we have x such that x is less than or equal to -2, comma, x greater than 3. So either can be satisfied. X less than or equal to -2 is here, or x greater than 3 as here. Now let's solve example 2c. This time the solution set is 3x minus 5 is less than x plus 8 and 5x is greater than x minus 8. So let's solve this. Clearly we need to do some tidying up first. So the first inequality becomes 3x minus x is less than 8 plus 5. We've taken all the x's to one side and all the constants to the other. Then tidying up gives us 2x is less than 13. And finally dividing by 2 gives us x is less than 6.5. And now for the second inequality. Again, taking all the x's to one side and the constants we leave on the other. Then tidying up, 5x minus x gives us 4x, and minus 8 is left as it is. Finally, dividing by 4 gives us x is greater than -2. So let's have a look at what this looks like on the number line. X is less than 6.5 is here, and x is greater than -2 is here. Since we're looking at the region which satisfies both, we're looking at the region x is greater than -2 and less than 6.5. In notation, this is the set of x values such that -2 is less than x is less than 6.5. And now for example 2d. Again, we have two inequalities for the solution set, and these also need to be tidied up. So solving the first inequality, we have x is greater than 2.5, and the second inequality we tidy up, taking all the constants to one side and the x's to the other, gives us 18 is greater than 6x, and finally dividing through by 6 gives us x is less than 3. And let's have a look at what this looks like on the number line. X is less than 3 is here, and x is greater than 2.5 is here. So in notation, because we're looking at one inequality or the other, in notation we have x such that x is less than 3 or x such that x is greater than 2.5, as shown. And this is, of course, the entire real number line. And finally, for example 2e, we're required to find the solution set for two inequalities again. So again, let's tidy up the inequalities. The first one becomes 2x is greater than 3 minus 5. We've rearranged so that all the constants are on one side and the x's on the other. Then we tidy up and finally divide by 2 to give us x greater than minus 1. Similarly for the second inequality, all the constants are brought over to one side, so we have 18 minus 10 is less than 4x, giving us 8 less than 4x, and finally dividing by 4 gives us 2 less than x. So let's have a look at what this looks like on the number line. X less than 2 is here, x greater than minus 1 is here. Because we're looking to satisfy both of these, we have x is between minus 1 and 2. So in notation, this is a set of x values such that minus 1 is less than x is less than 2. This brings us to the end of this session. If you have understood its contents, you should be able to solve linear inequalities using manipulation and number lines. Thank you very much for listening. To understand this topic in greater depth, do take a look at the exercises related to it in your textbook.